How many times have you been out in the world, places like stores, businesses, organizations, and just found random Ethernet jacks hanging out? If you've ever just kind of plugged into one of them, you might be terrified to find that in most places you go, that will probably drop you directly onto their private network. Security teams love this one neat trick kind of thing. Maybe the smart, simple thing would be to just unplug them at the patch panel until you actually need them. But then you definitely won't make it onto those Instagram pretty cable kind of reels, where everyone has perfect one-to-one patching with their fancy light-up switches and stuff. But also, it's kind of a pain to send a tech out to repatch something every time something changes, or even just to change a switch config. So wouldn't it be cool if we could just plug in our devices to any port on the switch? They would magically find the correct VLAN for that type of device, and if they're a member of our organization, they'd be authorized. Doesn't that seem neat? Now, all of that is possible with 802.1x wired port authentication, and that's what I'm going to set up in this video. This is very similar to some of the other Wi-Fi videos I've made in the past, MAC-based auth, EAP-based auth, and so those concepts are going to carry forward here. So if you want to better secure your wired network, then come along on this adventure. So before I get too far off into the weeds, here are some of the devices and the terminology I'm going to need in this video. So this little guy here, you might call him a managed switch or a small router. It's a MikroTik Hex S. So the cheaper version without SFP is like $60 right now. It's got some gigabit ports. It can do routing on the CPU. It can do switching on the switch chip. And it can do 802.1x and Radius. Pretty much all managed switches, like properly managed switches, should be able to do .1x with Radius. Not all of them can necessarily do RADSEC though. So that's the security level on top of Radius. In the IEEE architecture, this guy is called the Authenticator, by the way. Authenticator. This little guy here is playing the role of my client device. It's running Kali Linux, but any operating system that supports wired networking should be fine with this. Windows, Mac OS, Linux, they all support .1x. For my other client, I have a security camera here. Another common use case of .1x is when you have a security requirement not to have unauthenticated ports like outside of the building. So you're concerned that someone might come and unplug your security camera and plug it into your network, that kind of thing. This security camera does support 802.1x. It doesn't support certificates though, so we have to give it a password. These two devices, which are authenticating with credentials from the device, so that's a certificate, a password from the device, these are referred to as a supplicant. Don't ask me where the name came from, I don't know. Now the third node in our hypothetical topology here is the Radius server. And this is what actually has the credential backend. It decides whether a client is authenticated or not. I'm going to implement that in a Debian environment. So if you have a VM or a container running Debian, that's perfectly fine. As for protocols, we have essentially three different protocols here going on: Radius, EAP, and EPOL. So when the authenticator wants to authenticate a client, it uses the Radius protocol to communicate that request to the Radius server. It may also include additional information such as the MAC address, what port on the switch it came in on, what switch itself it is, things like that. That is the Radius traffic, Radius protocol. Now when one of the supplicants wants to authenticate itself, it needs to prove its identity to the Radius server, not to the authenticator. So that protocol from the supplicant to the Radius server is called EAP. Now EAP needs to be carried somehow, so on wired Ethernet, it's carried in a frame known as EPOL. Once it gets to the authenticator then carries the EAP frames in Radius. So EAP ends up on EPOL on the wire, gets to the authenticator, gets encapsulated in Radius, and gets transmitted through the Radius session. So now we have three places to start. We can configure the Radius server, we can configure the authenticator, we can configure the supplicants. This video is brought to you by Raycon and their everyday earbuds. Now, I spend a lot of time behind the scenes setting up, doing research, etc. to make these videos. And it's easy to just pop in my everyday earbuds, put on a podcast or maybe some music, and listen to something while I'm working. Now they're pretty comfortable in the ear, thanks to the multiple sizes of silicone tips they come with. They also have a pretty long battery life. And they're fast charging. You can recover 1.5 hours of battery in only 10 minutes. So I'm down here sitting with these guys again. Got to install 3 copies of everything, as one does. And I can pass my time by listening to the IPv6 Buzz, a favorite podcast of mine on my everyday earbuds. I also spend plenty of time working with IT equipment that can be kind of noisy, so the active noise canceling features are very welcome as well. They have a selection of colors available. I chose a nice blue for mine because it matches my personality. They also have a wide variety of cases available to personalize it even further. Follow my link in the description below to get an exclusive discount on your everyday earbuds. Now back to the video. So the first step in this journey is we need a Radius server. Radius stands for, check my notes here, Remote Authentication Dial-In User Service. If you want to know about the history of how this was set up to use for dial-up ISPs for people logging in over PPP, I've got a video probably in the description down there from another channel that does retro computing. But anyway, this was designed to let authentication servers, specifically in this case dial-in modem routers, connect to a backend database and authenticate users. So Radius runs between the device that's doing authentication and the server. It's not involved in the client. In the past, I've set up Radius before, and I think it was that video up here, and I just used normal Radius on UDP port 1812, which is like the standard, and this is pretty insecure. So a few months ago, a vulnerability called Blast Radius was announced. Probably a link in the description for that too. Basically, Radius is not encrypted at all. All the data that flows over Radius is in the clear, unencrypted, which is not a good thing. However, it does have authentication using a shared secret and the MD5 hash. Now, the MD5 hash is not cryptographically secure. It's been broken for probably a decade now. That doesn't mean it's easy to attack, but it means it's possible. And secondly, these shared secrets are just like a string of letters and numbers that someone can type out, so they're not really secure either. We're not doing any like password-safe hash algorithms. It's just a basic MD5 hash. So as a result of that, I'm also going to be setting up a RADSEC in this video, and that uses mutual TLS to encapsulate the Radius traffic. So my network switch and my Radius server are both going to get TLS certificates. They're going to set up a TLS tunnel and exchange Radius through that. That gives Radius encryption and security without having to deal with the ancient MD5 protocol. So anyway, I'm going to come over here and I'm going to create a container to run Radius in. I really like using Debian 12. Debian 12's latest version right now. You should probably just use whatever is the latest Debian. Don't need that much space. 8 gigs is probably fine. I don't know, 2 CPUs. Probably don't need that much RAM for Radius. And we're just going to do IPv6 only because we don't need any IPv4. If you're not all about that LXC container life, you can of course run this in a Debian VM. That is perfectly acceptable. All the instructions will work the exact same way. So I'm going to do a usual apt upgrade. And then we'll get to installing. So then I'm going to install FreeRADIUS. By the way, all of the installation instructions, all of the config files added in this guide, a bunch of that documentation will be on my blog, link in the description below for that. So if you're getting stuck and if you don't want to type out the commands as they're in the video, go to the blog, you can copy and paste from there. So now that it's installed, I'm actually going to stop it. And then we can go to the config directory. So FreeRADIUS configs are in etc FreeRADIUS 3.0, and we're basically going to live in this directory from now on. So for the rest of the video, all of the paths I mentioned will be relative to this config directory, etc FreeRADIUS 3.0. So cd to that directory, going to be here for a long time. So next up, FreeRADIUS has some quirks. One of these quirks is that later on, when we do TLS validation, it's going to need a temp directory. This makes perfect sense. Systemd has decided that their solution is to give every service its own private temp directory if they ask for it, which also is a very logical solution. FreeRADIUS, however, does not like that solution. It wants to have a folder which already exists that it can chown and chmod itself to, and Systemd doesn't let it do that. So I have a Systemd override that will create a temp file and a temp directory that is not deleted by Systemd every time, and which Systemd does not manage the permissions of. So we're going to system control edit. And that gives us this edit file here. So this is the original FreeRADIUS Systemd unit. So we need to add our edits between these lines up here. Just copy the edits and paste them in. Save that and we're good. Next up, I'm going to set up FreeRADIUS to do RADSEC. Now this file I'm going to paste in is new. It's called sitesavailable/RADSEC. But it's based on an example called TLS. So if you want to read the full list of all of the possible options, you can open that TLS file. It's like hundreds of lines long, but that's how all the FreeRADIUS examples are. Anyway, my example is a pretty decent starting point. So copy and paste this guy in. So this is the config for RADSEC. So we have a listen directive, so this tells FreeRADIUS to listen somewhere. And then we're listening on : which means any IPv6. If you want to use legacy, you can use a star instead. And we're using port 2083. Traditional radius would need a separate auth and accounting port, but we can do those together because we're on TCP. We're going to use the default virtual server, and I'll get to what that means in a bit. So we have some client limits here. If you have any problems with this, you can raise these. And crypto. So these files are rather important. So we have the private key file, certificate file, CA file. These are all going to be for the server side. So the server's private key that it uses for RADSEC, the certificate it uses for RADSEC, and the trusted CA list for RADSEC peers. I know the certificates in Radius can be kind of confusing. Essentially, we have a number of different connections going on, and those can use different certificates. So when we encrypt a Radius connection with a RADSEC, we're creating a TLS tunnel between the authenticator and the Radius server. That is encrypted using mutual TLS. So the client side needs to have a client cert, which the Radius server needs to trust. The Radius server needs to have a server cert, which the client needs to trust, or the client sometimes doesn't, but whatever. And so this is the key, the certificate, and the certificate authority that we use for validating the RADSEC connection. This is not the key and the certificate and the authority we use for clients over EAP TLS or PEEP. Those are going to be a different certificate in a different place. In this case, we support TLS 1.2 and 1.3. I've enabled a session cache, so if you want to use that, that's fine. So down here in verify, this is where we actually verify the client cert. So we call OpenSSL and tell it to verify against a CA file. So this root.pem is how we validate the client cert, which gets put in the temp directory. And then finally, we have this client's RADSEC section. This is where we put clients and shared secrets. In the old days of Radius, we would put each individual client's IP address here because Radius is too old school to use domain names or reverse DNS. We would have some shared secret for all of them that was hopefully randomly generated, not just like correct horse battery staple. For RADSEC though, we are already authenticating the TLS connection using a client cert. So it would not be unreasonable to just put anything in here, like : /0, so all IP addresses. Also, you can put a shared secret if you'd like, but the RFC says the shared secret has to literally be the word RADSEC if you use RADSEC. So you could put your entire network here, /48, you could do : /0. You could also do localhost, but this is what I got going on. So I put in my entire 48 here and rely on client certs. Now one last thing, we have to enable this. So the file we just put is in sites available, and we need a copy of it in sites enabled. So we do ln-s /sites available /RADSEC. It's going in sites enabled /RADSEC. There we go. So now we can see we have our new RADSEC file in sites enabled. So FreeRADIUS is not exactly the biggest one for documentation. Their style of documentation is writing out very long example config files with lots of comments. That would be great if you just kind of choose which example you want to start from and copy and paste it into your config. But they don't do that either. All of the example configs are functional, and they've just kind of commented out parts that they don't need. So you have to have like dozens of these config files that all do a bunch of different things to have a working setup. And it's a lot of a bit of a house of cards feel. So anyway, I have rewritten one of these files that deals with EAP TLS and EAP PEEP. And we're going to take a look at that file as I've modified it and as I'm going to use it today. So if you want to, you could move the example to a backup. So I'm going to do that, and then we'll edit mods available /EAP, and we can paste in my example. So I stripped out a bunch of stuff that's not necessary, but in the end, we have a couple sections we still have to configure. So come down here to TLS config TLS common. So this is what we configure for TLS. So server side, we need a private key file and a certificate, so we have the full path to those. You'd obviously put your own paths in here. We also have the root.pem, which we trust for clients. FreeRADIUS defaulted to server preference, but generally we want to use client preference for server ciphers. In this case, we're using TLS 1.2 only, allegedly because of bugs in some supplicants. That's what FreeRADIUS claims. I left it there because it's not a huge deal right now, but whatever. Next up, like earlier, we have a verify. So this is the command we use to verify their certificate. So again, I have this root.pem here. This is the client's certificate authority, and it will call OpenSSL to verify a client certificate. Next up for TLS, we just tell it to use the TLS common configuration. This is what we're going to use today. And if you like usernames and passwords, you can also use EAP, and I've set that up as well. Now, when authorizing clients, there's a file called the authorized file. If you watched my previous video where I did MAC address-based stuff, it might have been familiar to you. We're not actually going to use that file today because there's a long chain of commands FreeRADIUS uses to verify an identity. And the way we have it set up now, once it validates the certificate is valid and was issued by our certificate authority, that's where it ends processing. So it's not going to continue and check that the username in the certificate was valid. And I've already done way too much FreeRADIUS in this video to tell you how to do even more FreeRADIUS config, so maybe that'll be a topic for like the next video or maybe even the one after that, because FreeRADIUS is like a nightmare sometimes. So last thing we need to start up our Radius server is a certificate, so it's time to talk about those. There's a lot of ways we can generate certificates here. We could have as many as 4 different certificate authorities involved in this. Most of the time you'll probably only have like 1 or 2. That's of course up to how you want to do your PKI infrastructure, how much you want to have localized to this, how much you want to use global certs, etc. So today we're going to end up needing 2 separate sets of TLS connections, and our Radius server is going to be the server end of both of them. Our first TLS connection is RADSEC, so this is between our Authenticator, which in this case is the network switch, and FreeRADIUS. So here, FreeRADIUS is the server, so it needs a server TLS certificate signed by really anything. The switch is also going to need a client TLS certificate to talk to the Radius server. Now these 2 devices just need to trust each other. There's no public certs involved in this. There doesn't have to be. You could create a single self-signed cert for all of your RADSEC and just use this for RADSEC if you wanted. If you have an organization level PKI stuff, you could generate certs out of that. That's probably the best way to go. The second set of certs we need are going to be end-to-end. So this is going to be from the Radius server to the EAP client, the Supplicant, WPA Supplicant. If we're doing EAP TLS, we need a server cert for the Radius server for EAP, and we also separately need a TLS cert for each client, for TLS client. If we're doing PEEP MS Chat with usernames and passwords, we just need the server-side cert. Now, almost always, these certs will be self-signed. You generally do not want to use publicly signed certs for this because there's no checking of names here. When a client's logging into the network, it has no access to the internet. It can't validate anything. All it can go on is what's in its cert store. So usually, when you deploy a client with a certificate, you're going to want to add your custom root certificate, and it's only going to be used for WPA Supplicant for EAP. That way, it will only trust your Radius server and not someone else's Radius server claiming to be the same domain name. Because again, the client doesn't know what the domain name should be. It doesn't have a domain name it's connecting to, it's just getting it from the network. So, I have a couple approaches here. FreeRADIUS comes with some example certs. I like to know how things work under the hood, so that's why I have some walkthrough examples in OpenSSL. Second, you could walk through my examples in OpenSSL, which I'm going to do now. And third option, if you're using my small step CA, which I had a video up on here, you can use those to generate your server and your client certs as well. One last note, if you want to do 192-bit mode for WPA3 Wi-Fi certs, now I'm not doing Wi-Fi today, but the same certs work for Wi-Fi and for wired. It's actually why it's called WPA Supplicant. So if you want to use 192-bit mode, we need all of the encryption we're using to provide 192 bits of security, not the usual 128 or less. For elliptic curves, this means we need twice as many bits as the security level we're going for. So we need a 384-bit elliptic curve key. For RSA, we need significantly longer. We need roughly a 7,000-bit RSA key to get 192 bits of security. And that would take a very long time to compute. So we're going to use elliptic curves today. You are, of course, free to use RSA 2048 or 4096 if you want, or, of course, elliptic curves. I'm going to use SEP 256 for this, which is a very reasonable elliptic curve. So first we have to generate the certificate authority. And again, you can generate multiple authorities if you want. So first we generate a private key. This just generates a private key. Then we use that to generate a self-signed root certificate. So we're going to use root.key to sign an X509, valid for 69 years, call it root.pem. I'm giving it all the information about my setup. So this is my cert for Radius for applr.net. And I've added some constraints that it is a certificate authority and that there can't be any more certificate authorities below it. So this is our root CA cert. After that, we just can view it, and that's it. So I'm going to go into the certs directory, because this is what I put in all my paths. We'll just paste that in and run it. So now we can see we have root.pem. It is signed by me. It's valid until 2093 for 69 years. And it is a certificate authority. Of course, you can create 2 authorities with 2 keys and 2 PEM files if you'd like, for your RADSEC and for your EAP. And if you really wanted to, you could actually create 3 authorities, one for RADSEC, one for EAP server, and one for all your clients. It's entirely up to you how you want to manage this, but I'm doing one set of PKI because that is a reasonable thing to do. So I also have an example here for server certs. Again, I set it up for 256-bit keys. If you want to go for 192, you can use 384. Here I'm signing it with the fully qualified name of the server. So that is the common name. I've signed this for server auth. I've added the policy for trust on first use for WAP. So EAP is the exact same whether we're using it on Wi-Fi or on wired networks. So I've signed this cert with the WPA3 policy of trust on first use. And that means if you use this for a WPA network, it'll ask the client, do you want to trust this server the first time they log into your network? Then it will trust it in the future. And then if that cert changes, it'll tell the client there's an error and not let them continue. The other option to sign this with is called strict. And in this case, you must manually load your root cert onto the client. It will not let the client trust it. So both of those are there if you want to use either one of them. So we'll do this export. So in this case, I'm raddb.applr.net. And we will run this. So I got my 256-bit key, and it's got the policy, and it's for web server auth. Now I could use this key and the cert for both RADSEC and also for EAP, but I'm going to create a second one just to show you how you do that. So we're just going to change this export to something else. So I'll call it ads.applr.net. And I can come over here and copy the rest of it again, except for that export because we just did that. And now we have another one, radius.applr.net for web server auth. Now clients work similarly, except we can give them a fully qualified name or like a user at domain name. Both of those are valid. Again, I'm using 256 bits. This one is just signed for client auth, not for server auth. And we're exporting a P12 for this, so we can share it over the network securely. So clients in this case are anyone who connects to the Radius server. So first of all, our Authenticator is going to connect to the Radius server over RADSEC. So the switch is going to need a cert to do that connection. Secondly, all of our users are going to need a cert if they're going to use EAP TLS. If you want to do EAP PEEP, which is the one that uses usernames and passwords, then you don't need a TLS client cert for those devices. Also, if you do Mac-based auth, those don't need certs either. So I'm going to do switch 5 first, so client is switch 5. Then I'll copy all this code. It'll ask me for a password. And now I've got a client auth cert for switch 5. Now I'll do another one. So this is my Kali Linux PC, so it's going to be called Kali, and it's a user cert, so I'm going to do user at domain. It's really, really common for user at domain certs to be for people, and for fully qualified domain names to be devices. So in this case, it's the Kali Linux box, which should probably be a device, but I'm just showing you how user certs work. And also when we do authorize later, we can check to see if these realms match up and things like that. Kind of neat. Okay, so now I got my Kali cert, my user cert, and it's good to go. So now we can finally set up the Radius server. Initially, when we're doing testing, we're going to set this up just by running it in the local console and not running it through the systemd service. This will cause it to print out a lot of debug information that will help us with debugging the setup. Once we get it going, we'll restart the systemd service and be on from there. So we're going to run FreeRADIUS -fxxl dev std out. So when we run this, it should say, oh, what did I do wrong? Failed to change permissions. Oh, I gotta create that. Okay, let's try that again. They are ready to process requests. We are ready to carry on. Also, you can see we've got auth accounting on TLS on 2083. We've also got all the other insecure ports. So you have V4, V4 accounting, V6, V6 accounting, and this guy, which is the inner tunnel. If you don't want to do insecure radius, I would recommend you turn that off or actually change it from star or : to localhost. So it's really helpful to be able to use the rad test tool to debug things. So if you change it from binding to everything to binding to localhost, then you won't be able to use insecure radius anymore, just RADSEC. So that would be in here, sets available default. Scroll down a bit, so we get listen. So this one's : I'm actually just going to delete this whole block, and then also delete the accounting block. And then for the V6 ones, I'm going to change it to : 1. Same with this one, : 1. So I'll use the V6 versions and then delete the V4 versions. There we go. So change these guys to localhost. So I pulled up Winbox here. I'm set up to configure the switch. It's called switch 5. I'm running version 7.14.3. That's the latest version that doesn't have RADSEC bugs. So when that blast radius vulnerability came out, everyone on Earth was trying desperately to patch it because radius is so widely used. Part of MikroTik's patch also broke RADSEC, so that'll get fixed pretty soon. So what do you got to configure? So we need an IP address for the switch so it can talk to the radius server. So I have one, we're good. I need a name, so I have a name, we're good there. I need to add the radius server here under radius. I need to add a certificate authority here and a certificate so we can do RADSEC. And I need to configure .1x server on each individual port. So first things first, I'm going to do the certificate first. So I need to import a certificate, and I'm going to need a P12. So in order to import, I need to have a file here. So I'll open the file browser, and there goes the P12, and there goes the PEM. And we can give it a passphrase. There we go. So I've got the root CA, which we're going to trust, and my own certificate, which I'm going to use. Next, I can come over here to Radius, and let's add the Radius server. So in MikroTik, we pick what services the Radius is used for. In this case, it's going to be used for .1x. You could also use it for wireless in exactly the same way. Next up, we need the IP address of the Radius server. Slightly frustrating here that it doesn't take a domain name for the Radius server. However, this doesn't seem that unusual for Radius clients to require an IP address. I don't know why they're just so ancient. Radius is just an old protocol. So anyway, there's the address. Protocol, we're going to use RADSEC. No secret for RADSEC. Port is going to be 2083. Certificate should be our certificate. So Radius is set up. And finally, .1x. So here's where we set individual ports. So we have the option here. I'm going to set ether 2 as a .1x port. So our option is .1x or MAC-auth, or both. So with MAC-auth, every time the switch sees a new MAC address, it'll do a Radius request with that MAC address as the username and no password. And if the Radius server accepts, the MAC address is authorized. Otherwise, declined. You still get all the information in the header here. You get the host name of the switch, switch 5 in this case. You get what port number it was plugged into if you care about that. Useful stuff to make authorization decisions. Now the other option is to do .1x. That's what I'm doing here. This is where we're not authenticated based on the MAC address. We're passing through that EAP traffic from the supplicant on the client through the authenticator to the Radius server. So that's .1x, which is the mode I'm using here. So then we have some options down here that are VLAN ID related. If the Radius server either doesn't return a VLAN ID, then we get put on guest. If the Radius server returns a rejection, then we get put on reject. And if the server can't be communicated with, then it puts it on server fail. And if you don't fill these in, it just won't authorize the client in that case. So we can say OK to that. And I'll do another one on ether 3 as well. So now I can see here both of these clients are unauthorized. They haven't authorized yet, so their port is inactive. Also, if I come here to the bridge ports, we can see that these two ports are not active. So there's no spanning tree path here, and there's no role. Interesting though, if I go here to interfaces, it shows the interface is running, but nothing is happening on it because it's being disabled by .1x. So there's nothing plugged into port 5 and it's not running. So now my switch is configured to pass through EAP traffic for Radius. This should be all I need to set up on the switch. Now I can set up the Supplicant. So it's finally time for the Supplicant, or the client side. So I've got my Kali Linux box here. I also copied my root.pem and my p12 file for the client over here, because I'm going to need them later. And it's finally time to plug it in and see what happens. Let's see what we got. So we got ETH0 link state up. So it detected the link, but we got no address. FE80 is just link local, so it didn't actually find an address. And if I pull up Wireshark here, let's see if we find anything. So we're sending out router solicitations, not getting anything. There we go, requested entity. So this comes every 30 seconds. So it came from the switch, and it's to nearest non-TPMR bridge, so that's not 2-port bridge, and it's an EPOL frame. So it's an Ethernet 2 frame, so no Internet Protocol address. It's .1x, and it is asking for request identity. And since I never configured anything, my client didn't respond at all. And since my client didn't respond at all, the switch has disabled this port, and it will try again in 30 seconds. So now I'll close Wireshark, and let's see how we can configure a connection here in Network Manager. So I'm going to create a new Ethernet and give it a name. We're going to do automatic v6, and nobody needs v4, and especially 802.1x. So we have lots of authentication types here, and the only two you really should be using are TLS or PEEP. So I'm going to pick TLS. Now I have some options here. So identity is the string that I tell the switch. Identity goes over the wire in clear text. It's not sent to the Radius server, it's sent to the switch. So this can technically be whatever you want. Some people like to just put this all as the same value and everything, so they're not leaking any information on the wire, for example. So I can name whatever I want. I need a CA certificate to validate the server side, and for that I'll select from a file and pick my root.pem. I need a user certificate, which is how I authenticate to the server. And again, I'm going to select from a file, and there we go, PKCS number 12, certificate bundle. So P12 includes both the certificate and the private key. If these were two separate files, you could pick them separately. And of course the password, which is used to encrypt the P12. So now that I've done that, I can hit save. It'll be here. It may use it. So now that I plugged it in, we got quite a handshake going on here. So we sent a request identity, we sent a response to it. It then requested us to do EAP TLS. We sent a client hello over TLS, etc. The whole thing went across, and it said it was happy. And then we started getting a whole bunch of traffic on the network, because this is normal network traffic. So if I look at my IP address, you can see I got a v6. I'm good with that. Can ping. It's all good. So now that we've done all that work to configure FreeRADIUS, which is a huge pain, now it just works, and we can rely on it for all of our switch ports going forward. Doesn't matter what port I connected this guy to, he's got a certificate, the network will trust him. Now this might seem a bit anticlimactic, but that's literally all I've got. I can plug a device with a certificate into my network, it'll get authenticated to the switch port, and it'll be good to go. If you want some examples of slightly more complex setups, you can also do things like assigning users to VLANs based on their identity. You can also do EAP PEEP if you want to do usernames and passwords. I have some examples for that in the config file on my website. If you want to follow along, I highly suggest you read that document there. It has all of the configuration examples here, all of the instructions, and I'm going to keep it updated with any changes or upgrades I might need. I know FreeRADIUS is not the most fun topic, it's quite complex to set up, but hopefully with this example configs, you can get started doing the same thing as I did with .1x. Of course, the same FreeRADIUS configs will work just fine for WPA as well, if you want to use WPA Enterprise with EAP TLS or EAP PEEP. So if you like these videos, let me know down in the comments. I have a Discord server if you want to chat with me about any of these topics. If you like networking and you want to see more of these Radius security kind of videos, let me know. I guess I'd like to know what direction you want me to go in. Don't forget the discount code for the everyday earbuds down in the description below. I also have a Ko-fi if you want to give me any money personally. Greatly appreciate that. And as always, I'll see you guys on the next adventure.